Hello everyone, my name is Manikumar. Today my topic is about bidirectional DC to DC converter systems to achieve critical power condition in DC to bidirectional DC to DC power conditioner systems. Major types of converters are there are three major types of converters. There are three major types of converters. They are buck converters, boost converters, buck boost converters. In buck converter, if we give input voltage of 20 volts, then it will step down the voltage like transformer, but the input power is not equal to the output power because the power is lost in the time of period and due to some sparks and I square R losses in the semiconductor devices, as the resistance in the semiconductor devices is more than the conductors. Advantages of the bidirectional converters: high efficiency, compact size. Advantages of the bidirectional converters: high efficiency, compact size, and less bulky, lower EMI. Efficiency will be more in the bidirectional converter when it is achieved to critical power conditioning, compact size, and less bulky, lower EMI, electromagnetic inference. Here we see in a buck converter it is placed in parallel. When the chopper is on, the output voltage uh, when the chopper is on, it short circuits and the output voltage is equal to input voltage. When the chopper is off, the output voltage is not equal to the input voltage. Higher efficiency boost converter, it converts one form of voltage into higher form of voltage. Suppose if we supply 100 volts, means it converts into 150 volts due to the it in time on period it supplies the energy of the inductor as it is stored previously. Now there is one more type of converter, buck boost converter. Abstract: converting interchangeable loads and sources on committed interpower connect is becoming more commonplace in the art of switch mode power design. Simple, robust schemes have ended up serving in strategically important applications such as those in DC bus system of NASA International Space Station and in the more familiar world of automatic hybrid vehicles. As more diverse sources of energy lend themselves to economical and efficient conversion into electricity, the need to streamline the delivery of critical power from one DC potential to another high efficiency DC regulation, it has been found that making adaptations to a proper proprietary switched mode resonant topology results in achievement of a reliable high performance bidirectional converter BDC. The flexible bidirectional converters offer in numerous applications bring significant economic and operational outcomes. Viewless metadata: converting interchangeable loads and sources on committed power interconnect is becoming more commonplace in the art of switch mode power design. Simple, robust schemes have ended up serving in strategically important applications such as those in DC bus systems of NASA's International Space Station and in the more familiar world of automotive hybrid electric vehicles. As more diverse sources of energy lend themselves to economical and efficient conversion into electricity, we need to streamline the delivery of electrical power from one DC potential to another becomes more apparent. Switched mode power conversion as well established means of achieving high efficiency DC regulation. It has been found that making adaptations to a proprietary established means of achieving mode resonant topology results in the achievement of reliable high performance bidirectional converters. The flexibility bidirectional converters offers in numerous applications bring significant economic and operational outcomes. Critical power condition: a power conditioning unit is required to convert the fuel cell generated DC power to use AC power. A conditioning unit typically consists of a power conditioning unit typically consists of DC to DC converter and DC to AC converter DC to DC converter is used to step up low magnitude DC voltage into higher voltage. It is 400 volt to produce 120 volts by 240 volts AC. These are the main types of converters. Now take a look about this for some time. Advantages of bidirectional converters are high efficiency, compact size and less bulky, lower image. Here bidirectional DC to DC converter means converting one form of DC into another form of DC. Means a converter, a chopper means fixed DC to variable DC. Variable DC means we will vary the output voltage at a fixed value depending upon the value of the inductor and capacitor, etc. Power conditioning, critical power conditioning means suppose input we are supplying 30 watts. Now that 30 watts should be available in the output side, even though when considering the time and time of period of the chopper. A power conditioning unit is required to convert fuel cell generated DC power to usable AC power. A power conditioning unit typically consists of DC to DC converter and DC to AC converter. DC to DC converter is used to step up the low magnitude DC voltage into higher voltage to produce usable 120 volts by 240 volts AC.